Scientists have made a bold announcement that disclosed a person's identity, a completely new realm distinct from anything previously recorded. NASA, well known for its groundbreaking studies, indicated that this recently observed astronomical phenomenon is captivating not just because of its size and course, but also due to the fact that it emits signals that seem intentionally generated. Could this be a huge discovery, indicating that we are on the verge of revealing information that could significantly reshape our perception of the entire world? Does this revelation imply the possibility of alien life existing on planets other than Earth? As we analyze NASA's astonishing findings, we could soon solve the puzzles surrounding these exceptional events. In 2007, NASA launched the Dawn probe to explore some of the most intriguing structures within our solar neighborhood, propelled by 3 ion thrusters. Dawn embarked on a mission, beginning with a 14-month investigation into Vesta, the second-largest small world in the asteroid belt. Dawn relayed detailed images and scientific data, revealing Vesta's complex landscape and extensive geologic background. Once its task at Vesta was completed, Dawn made its way to what many consider to be the most thrilling aspect of its journey. It's an in-depth examination of the dwarf planet Ceres. Thanks to its ion propulsion system, Dawn was able to escape Vesta's gravitational pull and move toward Ceres, a feat unachievable with standard chemical engines. These thrusters delivered gradual but sustained acceleration, allowing Dawn to travel far and wide and enter a stable orbit around Ceres. First sighted in 1801 by Italian astronomer Giuseppe Piazzi. Ceres is the largest object in the asteroid belt located between Mars and Jupiter. For decades, it was thought to be the smallest dwarf planet before its classification changed in 2006, with a rough estimated diameter of 950 kilometers. Ceres remains the belt's largest object, making it one of the most intriguing celestial bodies due to its remarkable properties. Scientists eagerly anticipated the initial high-definition visuals of this mysterious world that revealed bright spots scattered across its surface, particularly in a large cavity referred to as a crater. These shiny regions instantly captured the attention of the scientific community. Before the first clear images we had of Ceres were low-resolution and blurry images taken by the Hubble Space Telescope, offering only limited insight. The potential for sharp imagery increased optimism for revolutionary discoveries. The mission aimed to enhance our comprehension of the solar system's beginnings and the impact of water's role in the formation of planets. These luminous patches, also seen on other small celestial objects, were believed to contain highly reflective substances, possibly residual salts after water had evaporated. This implied the potential for cryovolcanism, a type of volcanic activity in which icy volcanoes let loose water or corrosive liquids instead of molten rock. The significance of these glowing features and what they reveal about Ceres is still unknown. Do they point to ongoing internal dynamics, or could they hint at something additional, extraordinary? Ceres stands out from other asteroid belt objects through its size, density, makeup, and ability to retain both water and ice. Unlike most rocky asteroids, it shares similarities in composition with comets, implying it could hold clues from the early development of the solar system. Dawn began its journey to Ceres after 2 years, approaching in early 2015, a crucial time as it prepared to deliver the first close-up images of the belt's largest structure. As the spacecraft got closer, it exposed a world previously concealed in the vastness of space. The early images showed a damaged surface marked by numerous impacts. But what truly intrigued experts and space enthusiasts alike were the glowing points dotting the otherwise muted rocky landscape. As the image quality improved, researchers proposed several possible explanations for the brilliant zones. Could they be icy surfaces that reflect light? Or maybe something totally different, from mineral-rich layers to frozen volcanic deposits. Further study revealed that the brightest area was a group of spots rather than a single spot. Multiple areas that sparkle, It was thought that these were salt accumulations that remained after water or brine had vanished, implying that Ceres currently possesses or recently had internal systems that can bring materials to the surface, where they would vaporize and leave behind glistening minerals. These insights challenged the long-standing belief that Ceres was geologically inactive, instead portraying it as a vibrant and complex world. The possibility of saline or underground deposits raises interesting questions regarding weather. Ceres could feature the essential components of life, often labeled an icy planet with a coarse yet absorbent shell. Ceres differs from most other small planets that are mostly composed of stone and metal. Its surface includes clay-like elements, ice, water, and carbonates, making it lighter and chemically unique. This points to a vast water reservoir. The outer layer is porous and retains volatile materials in a way more similar to comets than to standard asteroids. Researchers suggest that Ceres features a distinctive inner layout, a semi-fluid mantle that surrounds a central core rich in both ice and rock. This middle layer most likely contains a mix of stone and salt water, enclosing a dense silicate center. The fact that such large quantities of ice exist indicates that liquid water could have been present, particularly if heat was generated from early radioactive decay during Ceres's formation. This extraordinary internal structure distinguishes Ceres from other inhabitants of the asteroid belt and raises significant questions about its geology and the importance of water in shaping celestial forms. Additionally, the discovery of ammonia-based clays on Ceres indicates it might have formed in the icy outermost regions of the solar system before migrating inward. Ammonia decreases salty foods benefit from water's freezing point, liquids that can flow close to or even at the surface. These observations not only broaden our knowledge of Ceres, but also form concepts regarding how other icy worlds in our solar region may have come into being. Cryovolcanism, a compelling and relatively rare kind of geological process, is vastly different from the flaming eruptions of lava that we observe on the planet. Cryovolcanoes, or ice volcanoes, eject liquids such as water, ammonia, or methane. In frozen environments like Ceres, these materials can be emitted as gases or fluids. In sequence, cryovolcanism is thought to be carried by volcanoes. Water filled with dissolved minerals to the surface, where exposure to space causes the liquids to vaporize rapidly, leaving behind sparkling salt traces. A perfect explanation for the bright areas captured by dawn. The most noticeable of these glimmering spots lies inside a crater, especially within a particular region labeled SP5. SP5 drew particular attention as a result of its extreme brightness, and observed changes over time, likely as a result of occasional water emissions. This suggests that icy activity is still taking place, or at least continued until not long ago. Beyond SP5, many other bright areas are scattered in Ceres, each with its own distinct characteristics. This common presence implies that cryovolcanism may be more common on Ceres than earlier believed. These glowing characteristics support the idea that Ceres isn't a frozen, inactive relic, but rather a growing, dynamic world. As dawn kept sending data, numerous surface features were discovered. A variety of sizes of craters covered the terrain, each marking an episode from Ceres' influential past. Each collision, regardless of the cause, interstellar objects like asteroids. Debris tells a part of the story of Ceres and adds to its multi-layered identity in the larger story of the solar system. Furthermore, the presence of ammonia compounds available in Ceres is another critical clue about its origin, since ammonia slows down the melting of water's point under certain conditions. Liquid water may have existed on or beneath Ceres's crust, perhaps in ancient times, or perhaps even right now. This supports the theory that Ceres came from the icy solar system's outermost regions and later turned inside out. That migration might help explain its peculiar characteristics, including its abundance of ammonia and signs of cryovolcanic activity. as researchers keep looking into Ceres' both the interior and exterior of the shell. Their findings have an impact on our understanding of how planets evolve, where life could emerge, and how geology works on frozen worlds far away. Once thought to be merely a cold leftover from the solar system's past, Ceres has demonstrated itself to be an intriguing planetary object. One that challenges outdated concepts and inspires a new level of respect for what's possible within our neighborhood. In space. The Dawn mission, because of its thorough and extended observation, played a crucial role in the disclosure of these facts about Ceres. It produced the most comprehensive scientific and visual data ever taken from this solitary dwarf planet. Dawn's legacy is essential to the comprehension of the solar system. Every signal from the spacecraft was removed, revealing additional mystery layers of Ceres as a dynamic, living world for a long time hidden from view. These scholarly advancements are just the beginning of an ongoing journey to decode the enigmas of the outer solar system. In the coming years, experts will undoubtedly continue examining the enormous data cache of Dawn, searching for additional signs of life-supporting circumstances, not just on Ceres, but on other icy objects as well. As space exploration progresses and new missions are launched, even deeper discoveries may await. Will we eventually find more certain evidence of cryovolcanism? Might we see more evidence of underground water beneath Ceres' icy surface exterior? Only time will provide the answers, but there is already one truth evident. The saga of Ceres is far from over.